Example problem 4-20. Graphically position the links for the small aircraft nose wheel actuation mechanism shown in the figure. Then reposition the links as the 12-inch crank is rotated 60 degrees clockwise from the orientation shown. Determine the resulting angular displacement of the wheel assembly. So what we're going to be looking at is how far this rotates over as this 12-inch link rotates 60 degrees clockwise. So let's jump into AutoCAD. So I've already gone ahead and drawn our base configuration with BC, our 12-inch driving link, located at 15 degrees, and D being the wheel assembly will be extending off of point D. So the first thing we're going to do to draw our second configuration is we're going to overlay our 12-inch link, BC, and then we're going to take our 12-inch link and we're going to rotate it around point B 60 degrees clockwise. Now when you're in AutoCAD, when you specify rotate, when you're rotating clockwise, you'll have to put a negative in front of the 60 degrees to designate clockwise. If you just put 60, it would rotate it 60 degrees counterclockwise. Alright, so now that we have BC rotated, let's go ahead and let's copy our joint C over. And we can rename it if it'll let me, to C prime, indicating that it's in our second configuration. Now to continue this problem, we need to figure out where point D is going to be located as our driving link BC, that 12-inch link, has rotated around. So we know D is constrained to this point A because A is on the frame. So we know that D is able to revolve in a circle around A. So let's go ahead, let's make a construction circle around A. We can go ahead and back that up. We can put it right on D. Okay, so now we have this arc. So we know that D has to locate somewhere on this arc. If it's allowed to rotate freely around A, it has to locate somewhere on this arc. So the next thing we need to do, we need to go ahead and draw another arc, because this arc doesn't help us, right? We know it's located somewhere on this arc, but not exactly where on this arc. So now we need to make another arc representing the length CD. So let's go ahead and do that. And this arc is going to start at our point C prime. Our length CD is 30 inches. And so that gives us this arc. So if C prime was fixed and point D was allowed to rotate freely about it, it would land somewhere on this arc. Now these two arcs intersect in two places. So we need to figure out where exactly, which place it's going to land. Now you have to use just a little intuition here. If you look up here, okay, really point D isn't going to land up here. It's just not. Okay, the way the mechanism's moving, it would have to jump. This is one of the inversions that we had talked about in our notes. So you really just have to use a little bit of intuition and realize that D prime is going to land at this intersection. So let's go ahead and let's highlight that now. We can label this D prime, indicating it's in our second configuration. And now all that's left is to go ahead and finish our mechanism's second configuration with some lines connecting A to D prime, as well as D prime to C prime. Okay, so here we see our first configuration overlaid on our second configuration. So we see that as this driving link moves 60 degrees around, that our wheel assembly, the link locating our wheel assembly, also rotates clockwise, but not nearly as much. So let's go ahead and let's annotate this. Demang. And let's get a measurement. And let's go ahead. AutoCAD defaults angle precision to 0. I would like to see a decimal place in there. So, as our 12-inch link BC rotates 60 degrees, correspondingly, our wheel assembly link AD rotates 16.3 degrees. We see that, something you've probably already seen, is the little text box saying the angular displacement of the wheel assembly is 16.3 degrees clockwise. I would like to highlight here this little degree symbol. The easiest way to get that is to just type %D, and that'll pop you in a little degree symbol. Something else that's fairly useful, won't be using this right now, but %C is diameter. There's a whole bunch of other of these, but those are kind of the main two I've found that I've ever used. So here you have it. Again, when you turn in your homework, I definitely want to see something like this. The original configuration overlaid with the second configuration. Any angle measurements, any other right linear measurements you may have used, leave on there. I definitely want to see these construction lines and your answer written out in a text box.